Welcome to video 2 for this unit on associations in data. In this video, we're going to focus on using lines to model data. Sometimes we can use a linear function as a model of the relationship between two variables. For example, here's a scatter plot that shows the heights and weights of 25 dogs together with a graph of a linear function, which is a model for the relationship between a dog's height and its weight. The model does a good job of predicting the weight given the height for some dogs. For example, this dog is 18 inches tall and weighs 40 pounds, which is modeled very accurately by the linear model. You can know this because the point is almost exactly on the line. There are other dogs that are not well modeled by this line. This dog is 27 inches tall and weighs about 110 pounds. This model predicts that a 27-inch tall dog should weigh about 80 pounds. So we say the model under-predicts the weight of this dog. On the other hand, the model over-predicts the weight of the dog that is 20 inches tall and weighs 17 pounds, because the model predicts a weight closer to 48 pounds. Sometimes a data point is far away from the other points, or doesn't fit a trend that all the other points fit. We call these points outliers. Outliers. An outlier is a data value that is far from the other values in the data set. What do you think the association between car weights and fuel efficiency looks like? Now that you have some data, what do you think a good linear model might look like? When a linear function fits data well, we say there is a linear association between the variables. Although it is not perfect, there does seem to be a trend in the data that is modeled with this line. Because the model fits the data well, and because the slope of the line is negative, we say that there is a negative association between the weight of the car and the fuel efficiency. In an earlier plot, we looked at the relationship between dog height and dog weight. Because this model fits the data well and the slope of the line is positive, we say there is a positive association between dog height and dog weight. Negative association. A negative association is a relationship between two quantities where one tends to decrease as the other increases. In a scatter plot, the data points tend to cluster around a line with a negative slope. Positive association. A positive association is a relationship between two quantities where one tends to increase as the other increases. In a scatter plot, the data points tend to cluster around a line with a positive slope. The equation of this fitted line is W equals 4.27 times H minus 37, where H is the height of the dog and W is the predicted weight of the dog. The slope is 4.27, which tells us that for every 1 inch increase in dog height, the weight is predicted to increase by 4.27 pounds. In our example of the weight of a car and fuel efficiency, the slope of the fitted line shown is negative 0.01. This tells us that for every 1 kilogram increase in the weight of the car, the fuel efficiency is predicted to decrease by 0.01 miles per gallon. When we have a negative association between two variables, an increase in one means there tends to be a decrease in the other. Sometimes a scatter plot shows an association that is not linear. We call such an association a nonlinear association. Sometimes in scatterplots, we can see separate groups of points. We call these groups clusters. Thank you for watching video 2 of 3 for this unit on associations in data.